So as Steve pointed out, I'm now at SNIC. Here are the logos here. But I am still passionate about performance, and this talk focuses specifically on images, on high performance images, and how can we make them fast. I will sort of say up front that this is a fairly broad talk. It's about what are the different steps you can do to make images fast in your network, in your system. So we're not going to go super deep into every one of those aspects, but I'll try to make sure that I have enough time for Q&A to drill in or ask any specific questions that I might not have kind of gone into that depth in the talk. So first of all, why images? Why do we care? So today, you probably see this is the mandatory HTTP archive slide in pretty much the beginning of every setup, showing us how challenging today's web performance state is. Average web page is about 2.2 megs today, and about 2/3 of that is images. So a very, very substantial amount of page weight comes from images, and also this portion is fast growing. This is a chart, again, from the HTTP archive showing how over the last 3 years, the size of an average image has doubled. And I'm saying size because the blue line here shows the number of requests, the average number of image requests on a page. And that has stayed fairly flat, but the total amount of bytes, the total number of image bytes on a page has grown substantially. In fact, has practically doubled. This is like 99 point some %. So very, very significant portion of our web page payloads today, and the fastest growing, or at least a very fast growing portion of it. And when you talk about the performance impact of those, it's not quite linear, but it is still very substantial. So images at the end of the day are a very kind of well-behaved component on our page, right? They're encapsulated, their own thing. They get loaded. They don't bother others. They don't block others except for sort of connection or resource utilization constraints. But they still take up the bandwidth. They still take up a time to render the page. So I ran a test a few months back on the top, I believe, 10,000 websites. And I just ran a simple test blocking all images on web page test on those top 10,000 websites and watched the delta in page load time. So it's not perfect metrics, it's not a perfect test, but give an inkling that web pages were roughly 30% faster over a 3G connection if you removed those images. So that's maybe a bar, or sort of an opportunity for us to try and aim for. So with this challenge, what can we do? And this is basically what we're going to be talking about during this talk. We'll focus on 3 areas that you can focus on to help improve the performance, or sort of squeeze the last byte, the last second out of your image performance. The first section, which probably is maybe the biggest one that we'll talk about, is image compression. How do you squeeze those images, make them as small as possible? The second portion would be about image loading. So it would be about how do you intelligently load those images in the fastest way possible, at least from a user perception perspective. And then the last piece, which we're actually not going to dig too much deep into, is some tips about how do you operationalize those? How do you sort of set up for scale? How do you set up for the ongoing and increasing complexity of image optimization? So with that, let's sort of dig into the details. We'll start with image compression, talk about how do we make images smaller. When you took, we sort of showed some stats before about the average or the total number of bytes of images on web pages. But also when you look at the individual resource side, images trump all the other resources. An average JPEG, which is the most prevalent image type on the web, is more than double the size of an average JavaScript, which is already too big, or an average CSS file. This also has some interesting effect when you compare it to another trend, which is responsive web design. So last October, so I guess about a year ago now, I ran a test identifying the responsive websites amongst the top 100,000 websites. And there were some interesting comparisons that you could do between the responsive websites and the non-responsive ones. One of the things that came out was that on the responsive websites, images were roughly 50% bigger. This is kind of where fact ends and speculation begins, but my sort of sense is that this is very much about retina readiness, about how those responsive websites, maybe on 2 aspects. One, they're newer websites, they tend, which kind of in today's design standards tend to be more visually rich, tend to put sort of bigger images on those spaces. And second is, they care more about retina. In general, retina is more prevalent, sort of high DPR, high device pixel ratio screens are more prevalent on mobile than they are on desktop and laptops, and therefore many times those websites just scale up to serve these high resolution images, and they serve those to all clients. I should point out that these are the sizes of images served to a non-retina display. We'll get to that later on. So how do we make images smaller? The first step that we should do, and this is kind of my first of 6 tips here, is to pick the right format. And with that, let me kind of take a step back and do a bit of a primer about image formats on the web. I'm not going to go in and explain how each of these image formats work, but to understand image compression, you have to have a certain foundation. So if you look at the web today, and you look at the distribution of image types on it, about 45%, yeah, I guess coloring is okay here, but 45% of those images are JPEG, 30% are PNG, and 23% are GIF or GIF. So those are really the image formats that we'll focus on, and then there's this 2% that are other, and there is hopefully a growing section in there of some newer image formats, so we'll touch on those as well. But let's explain GIF, PNG, and JPEG. There's a thing about image format naming. I really don't know where it came from, but like GIF is supposed to be pronounced GIF, PNG is supposed to be pronounced PNG, or not. Maybe it should be PNG. WebP, when they launched, actually explicitly stated that it should be pronounced WebP, as like the first thing you read about WebP is that it should be pronounced WebP. That's the most important thing. So I'm going to take liberty here and call it whatever I want, but just I don't get the drama. Images tend to invoke drama. So let's talk about GIF first. It's a pretty old format. It's 28 years old. It supports some basic colors, 256 colors. It supports simple transparency, so you can say that sort of sections of the image are or are not transparent, but you cannot make them partially transparent. And of course, probably its primary contribution to society is animated GIFs of cats. Animated GIFs, with all the formats, and there have been more attempts at animated image formats, GIFs rule. Now, GIF at the time when it was launched, above and beyond, maybe the sort of technical limitations of it, was also patented. And CompuServe at the time was starting to show some force and demonstrate that they might go after users of GIF if kind of using their patents, trying to sue for some payment. Those patents have now expired, but at the time, that was one of the drivers for the creation of PNG. PNG, portable network graphics, I believe, is a little bit newer. It came after GIF. It's 19 years old, so it's still ancient in technology terms. It supports richer colors. PNG 8 and 24 are the most common ones. It can even be more high-res than that. And again, kind of its key, maybe visual innovation is the notion of alpha transparency, that you can have a section of the visual be partially transparent, and you can kind of see through. You can layer your image. And as I pointed out, GIF had these problems with patents, so PNG was very explicitly not patented. It was sort of free for all to use and promoted. So with PNG, we got our first image compression technique, which is convert your GIF to PNG 8. This is a study run a long time ago now, at this point 6 years ago, by Stoyan Stefanov, that converted many different GIF images into PNGs. The green lines there specifies the size of the GIF, and the blue line shows the size of the PNG that resulted from it. So a very, very simple optimization, pretty much without fail, is to convert your GIFs into PNGs. So, small but significant. Of course, you cannot do this for animated GIFs, but it gives us sort of a first inkling and a first indication that image format is one of the techniques for image compression. Just sort of using a better format or the right format for the job can squeeze bytes. We're not getting into the depth of how PNG compression works, but fundamentally it's 7 years newer, or 6 years newer, whatever it is, 9 years newer, I guess, than GIF, and it introduces some smarter delta encoding that just sort of intelligently identifies or relies on the fact that different pixels within an image are often similar to each other, and therefore tries to squeeze those together, along with just some newer compression techniques. So this was GIF and PNG. And then the third and probably most important image format on the web today is JPEG. JPEG was created somewhere between GIF and PNG. It's about 23 years old. It supports kind of rich palettes, 24-bit colors. And it has no transparency support. That's still one of its primary shortcomings when you talk about whether you want to deliver an image as a JPEG or a PNG. So that's just a limitation of the format. And the other kind of key thing that differentiates from PNG and GIF is that it is a lossy format. Now, lossy is a fairly kind of detailed term. We can get into sort of lossy versus lossless in various ways. But this is sort of the easiest way to understand lossy versus lossless, which is if you were to take a bitmap, just no matter how it's encoded right now, you were to convert it to JPEG and then convert it back into a bitmap, you're not going to get the same thing. There's going to be some data that is forever lost in that transition. In the case of JPEG, it's done through some intelligent algorithms that try to, and math, that try to make the least noticeable aspects of the image get dropped so that the image is as similar as possible to the original while being much, much smaller. You have these two practically identical shades of gray. Can you just merge them into one? As well as factoring in some human perception. But no matter how you spin it, some data is lost, hence the format is lossy. While lossless is one where you can retransform as much as you want, and you would not lose information. And this is just sort of an example about JPEG, which is important when you talk about decoding times, which is JPEG's primary means of loss is that it splits up the image into a YUV or a YCBCR format, which basically means it separates the luminance from the sort of bluish shades from the reddish shades inside the image. And then it turns out that we humans perceive these things differently. We're much more sensitive to differences in brightness of an image than we are to its shades of blue. So the shades of blue and the shades of red could be merged better. So JPEG is a lossy format, and it does all this fanciness. And as a result, especially for photographs, it is substantially smaller than PNG. We'll talk about quality ranking of JPEG in a moment, but at a reasonable quality, at a quality that most humans would not be able to perceive the difference, for photographs especially, but for many types of images, JPEGs can easily be 5 times, 10 times, 20 times smaller than a PNG. And for minimal or no real visual or sort of perceived difference between the formats. So from an image compression perspective, step 2 is whenever you can use JPEG or use a lossy format. It's lossy, meaning it lost some information, but usually that yields to very, very substantial file size savings. Now, as we pointed out, though, you can't always use JPEG in part because of the quality component, and in part because of its transparency requirement. And also, as you might have noticed from the years, these image formats are not very new. And you might think that technology has evolved somewhat over the last 20 years, and that we might have some fancier algorithms or newer techniques to compress images better today. And if you thought that, you would be right. So a few years ago, Google released a new image format called WebP. There have been a bunch of new image formats. I'm just going to touch on a few of them. WebP was probably the one just sort of being Google, best marketed and promoted. And WebP is a new image format. It's only about 6 years old, I think now, 5 years old. And it uses just newer technology. It uses some innovations from the video space. In fact, WebP is the picture version of WebM, which is the media or the video version of some video protocols that have been encoded. So it sort of built on the back of online video that has improved a lot over these years. It has a lossy and a lossless format, hence the comparison to PNG and to JPEG. And it is substantially better than those. These are specifically the numbers from the Google studies when it was released, but they've been verified and vetted many times. I personally ran some tests on these and saw similar numbers. Vice ran some tests on them. I think at this point the WebP numbers have been quite fairly substantiated. So WebP is a better image format than PNG and JPEG and GIF, except for the fact it doesn't support animation. Well, I guess it does, but it doesn't really. It officially does, but it doesn't work. However, its shortcoming is that it's not supported everywhere. WebP, being Google, is supported by the Google-friendly browsers. It's supported by Chrome, has been since its inception. Opera uses the same sort of Blink underlying engine, so it supports it as well. Opera Mini and Android and Chrome, all the Google-friendly browsers or the Google-driven browsers support WebP. Windows or sort of Microsoft has its own in Internet Explorer and even in Edge have their own format called JPEG XR, which is arguably not quite as good as WebP, but it's still better than its predecessors, and that's supported on IE-related browsers. And Apple supports JPEG 2000, which is yet another format, which is only supported on iOS devices and on OS X, on Safari on OS X. So there are all these new image formats that are supported only by a subset of browsers. So before we sort of dig into those, just to sort of share some more recent information or evolution in these, there are actually two new players that came into the image format scene. One is called BPG. It was created by Fabrice Billard. I might be butchering his name here. Was the creator of FFmpeg and a bunch of other components. And it is, like WebP is the picture version of WebM, this is the picture version of Age 265, which is a new video codec, also called HEVC. So Mozilla, if you noted before, I said WebP is supported by Google-friendly browsers, JPEG XR by the IEs of the world, and JPEG 2000 by the Apple ones. Firefox remains unaccounted for in that list. And Mozilla has actually run a test, and they determined that HEVC, which is the sort of this video format, is actually better than all of those. They ran the test on a different benchmark of images, and they measured it slightly differently. There's no one measure of what makes an image format better. So BPG is a new image format that builds on HEVC and presumably is the one that Mozilla may back. They haven't made those statements. It's only been released in the last few months, I believe. FLIF or FLUF or FLIFE. I guess I could coin this now. I could just alternate because nobody has coined the term here. So FLIFE is about 0 years old. It's only a lossless image format. It's progressive, which is nice. We'll talk about that a little bit more later on. It is not supported by any browser out there. I think it's like a month old or a couple months old. But it's showing some really, really promising numbers. The creators claimed that it is 15% smaller than the lossless version of WebP. This is the creator data. Actually, I was in contact with a company called Cloudinary that do image management, kind of image optimization, and they ran some tests. They recently blogged about, I think earlier this week, on Monday or so, they posted a blog post comparing FLIF to the different image formats. And basically, their study shows that it's only about 2% smaller than WebP. This is sort of one view of it to say PNG is the benchmark. How much smaller is FLUF? And then this is a comparison between the new formats to the different image formats. So, on the surface, it's not that much better based on these stats. There are some 100+ commits that have been made to this format in an upcoming version of it, so it'll be interesting to sort of see the reruns of those. Probably would improve it. And there also have been some other comparisons around encoding time, which shows it to be, at least based on the Cloudinary data, it shows it to be not as fast as WebP. So like WebP encoding is faster. However, one interesting stat about FLUF is that it is especially good at high-resolution images. So if you look at this part here, you see that the green line, which is FLIF, versus the orange line, which is WebP, the gap is bigger at this size than it is at the beginning, which is the low-resolution images. So it's possible that in the future of the web, as screens become high-resolution, as we serve high-resolution images, this format would be even more friendly. So we've got ourselves an image format extravaganza. Different image formats. Nobody agrees. Everybody wants to support or back their own horse. In sort of today's world where browsers have generally come together to standardize and create things that are portable between systems, the image formats seem to be going in a completely different direction. Because FLIF and BPG, just need to choose a name for that one. And BPG are not supported by any browser. I didn't list them here, but the three formats that are useful in the wild are WebP, JPEG XR, and JPEG 2000. Each of them is better than its predecessors, arguably in that order. And each of them has some different means of authentication. So I think what's pretty clear, what we should take out of this beyond the general knowledge, is that we have to be better at being able to absorb these new image formats, right? This is a field that hasn't really seen much innovation in a good sort of 15 or 20 year stretch. Now there's all these new image formats coming in. Now that they're out there and the awareness of the performance is growing, there's a lot of noise around it. We need to be prepared for this, we as the web community, as website owners. So how can you do this? How can you absorb these new image formats into your system? I'll talk about a client-side and a server-side technique. On the client side, you can use the picture element. I'll talk more about the picture element when we talk about image loading and responsive images. But specifically, it's a new HTML tag or element that's called picture, and that allows you to provide multiple sources for your images. And one of the fields or one of the attributes that it supports is type. So you could provide a picture element that says, I support all these different types. And the browser should intelligently say which of these image types does it support and choose the right image to download in the order you specified. So this is one technique. It's good. It's very easy. Its primary downside is that if you start converting all your nice little, compact image tags into this, your page is going to get bloated very quick. And also, every time a new image format comes along or some changes like that happen, you're going to need to change your entire HTML sets. So another approach you can do is make this a little bit more dynamic and use it on the server side through conditional delivery. So the flow would be roughly like this, and I'm not giving exact decisions, but pretty much any intelligent-esque CDN or caching layer that you have, or some sort of front load balancer that you have, should be able to handle this, which is you request your images through some sort of routing entity. I'll refer to a CDN. It could be at your origin as well. It's important that it be the one that caches those images later on. So you get the request, it gets to the CDN. In the case of a Firefox or sort of an unidentified request, it might just get the original JPEG image. If the request comes in with an accept header that says image/WebP, then you know that this browser supports WebP. WebP is very good at this. All the clients that support WebP today communicate this, and I don't think any that doesn't support WebP communicate it. So in this case, the CDN can go to the origin and ask for WebP, or the origin can make that decision. But what's important here is that it's important that the CDN or the cache element here would cache it separately. If it doesn't cache it separately, you might find yourself later on having some user from Firefox come in and serving them a WebP. So the cache here has to incorporate this accept header into its key. And today, for WebP, it's very, very clean. For the other formats, not so much. Specifically, IE and for iOS, there are no indicators. There's no clean accept header that says serve me a JPEG XR or serve me a JPEG 2000. So you have to do user agent detection. This is improving on the IE world. It is improving with Edge, with the new browser. It will send an accept image/JXR. Before that, you can identify Microsoft IE 10 plus. JPEG XR is supposedly supported on 9 plus, but there are all sorts of problems with it on 9.9. So just go from 10. 9 is fairly extinct anyway. And for Safari, for JPEG 2000, you just need to do user agent detection. Okay. So this was a bit of a blurb about picking the right image format, which is, I guess, one of the two. It's hard for me to balance key techniques for image compression to make your images smaller. I'm going to take a bit of a pause here because I'm going to cover a lot of content and ask if there are any questions about these before I move on. Yes? So the question is, how do you create those image formats? So I guess I don't have the links here, but if you Google any of those, all the new image formats, so the old ones clearly are supported by the different environments. I do have a slide that talks about encoding well, so there are good encoding tools that I'll recommend. Specifically, the new image formats, JPEG XR and WebP, JPEG 2000 I don't think has its own encoders, ship when you Google WebP or you Google JPEG XR. Those, Microsoft and Google have provided good encoders that you can use with those. They're not supported in Photoshop, but frankly, you shouldn't be using Photoshop exported images on the web anyway. You should be running them through a good encoder to make them kind of just encode them better and smaller. Other questions? Yeah. So the question is, why is WebP not more popular? I think so. There's a combination here. I think one, and maybe the primary challenge is still awareness. I think many people are not aware of WebP. It is still new. As much noise as it has made in certain circles, the word is still getting out there. And the second, which I think is very substantial, is the fact that it introduces a complexity. If you want to serve WebP, you can't just change your images to say WebP. You need to now introduce either that picture element or the smarter delivery. And that's both more effort, so you need to care more to do it, and also requires a certain amount of stack that you may not have built. So I believe that the adoption of these new image formats is going to lag, or is going to be very slow until we have these good means of delivering different images. I think picture goes a long way in doing it. It just makes your HTML quite cluttered. Yes? Yeah. So on SVGs, I didn't talk about SVGs. Vector-based images are awesome for the cases where you can use them. If you try to take a photograph and encode it as vector, you would be serving an enormous image, an equally enormous and equally sharp enormous image to everybody. But yeah, don't. If it's an icon or something, oftentimes, if you can do SVG, do SVG. Yes.
You're talking about the CDN using the accept header as part of the cache key.
Yeah. Well, first of all, I would say it's arbitrary. Either it's supported or it's not supported, and I would like to think that anybody that says that you can add the accept header to the cache key, it would be deterministic. From what I've observed, so if you're using something that's sort of homemade, it may or may not support it. But if you look at Varnish, if you look at Fastly, if you look at Edgecast, if you look at like pretty much all the CDNs today would have some means of supporting this. This is not dissimilar to what we've done for REST, for responsive design. So for responsive design, oftentimes you would want to serve kind of a slightly modified HTML for a mobile client versus a desktop client. So this is sort of similar, except in REST, many times you could say just don't cache the page, while in images, you definitely want to cache those images.
And do you think as moving forward, we should then potentially consider dropping the extension, because it's a little bit misleading?
Yeah. So the extension, it's a good question. The extension today is its only usefulness is when the file is saved onto the machine and you double click it to know which software to open this in. On the web, inside the browser, it has no meaning whatsoever. It's all about the content type that got received. And even that content type is oftentimes omitted because browsers today sniff the content. They look at the bytes and they figure out whether it's one format or another. So yeah, it's interesting. I've seen a couple of attempts to call this a .image, a .img. There's some questions. I actually didn't touch on it here, but there's also a challenge about what happens if somebody saves that image. So what if you right-click? Facebook had this. So Facebook used WebP, and their users, or they got some outrage from users who, this was very much early days in WebP, who would right-click and save an image to their desktop and then wouldn't be able to open it. So first of all, Chrome now opens those by default. But the second is, I believe Facebook has implemented this, that you can capture those events of a right-click and a save and make the image kind of save it in a more generic format, or download an image in a more generic format. It's not that clean and not that simple, but I think in those examples, or in those cases where somebody does a save as, you want to make sure that you serve the right extension on the web. You might as well call it a .image to not mislead. Okay, let me continue, and I'll take questions at the end as well. So this was about picking the right format. The second thing we're going to talk about is controlling quality. And this is the second aspect of image compression, and yields sort of similar scale results. So quality is only important, or the quality ranking is only important when you talk about lossy formats. So I would heavily focus on JPEG for much of this. With lossless formats, there is no notion of quality. You always get the exact same bitmap. So as you encode, you can encode in different ways, but you would always get the exact same bitmap. In the case of a lossy format, usually there's a question about how much do you round. If I said that there's these two shades that are similar, and I want to decide to merge them, what's the gap? What is similar? How similar it is? Now, in reality, quality is much more complicated than that. It's not just a number difference between those, but rather a parameter that feeds into a more complex formula. And as a result, it's not quite that simple. A quality size or a quality difference of 20% does not equate to 20% difference in the byte size. And in fact, quality tends to be nonlinear. So this is an example of one image on, re-encoded in different qualities, and you can see on quality 90, it would be 66 kilobytes. If I just remove that 15 points to 75, I would get an image that is almost half the size. But just reducing the quality kind of roughly correlates. You could think of it as visual perception. If I lowered that again to 40, so I cut the quality almost by half, I cut the file size by less than half. So it's not linear. You get the best, yield the best rewards when you go from very high quality to sort of mid-range, mid-high ranges. But it is still very valuable. The challenge with quality, and when you talk about how low can you go, really comes down to artifacts. So, this is an example of a slice of that image. So it's the same image. I just sort of sliced it so we can look at it. And you can see that in the high version versus the 75 version, I think you'd be hard-pressed. There's a few artifacts here from the projector, but you'd be hard-pressed to find a difference. If you really were sharp, you would notice that over here you get a little bit more things that used to be round, get a little bit more blockish. And here you can see that what used to be kind of a round line suddenly becomes these steps. Technically, that's because JPEG encodes on an 8x8 pixel block. So there's oftentimes you'd find squarish things. But it means that you have to consider the quality rank for you. And there's no really great number to go with. But I would say that try to aim at the 70, 75, 80 as a good default to just sort of aim at and see how low you can go. Quality, another thing to sort of note, especially combining it with the image formats, is that quality is not actually a part of the definition. It's not a standard. Quality 70 in one image format, or even in one encoder, would not be the same as quality 70 in another encoder. So you have to look at your encoders and look at their results. So I said 75, and I threw that magic number out. It's very easy to just sort of have these numbers. It's convenient, but in reality, they do vary by different encoders. So test those. And then beyond that, when you talk about WebP, the quality curve is very, very different as well. So if you were to use WebP, make sure that you use the right quality metric for it. I actually don't have off-the-cuff numbers for what the number is that you should aim for in WebP. But as you can see from this graph, you can be far more aggressive. So this graph shows this is the similarity line, which is there are a variety of algorithms, SSIM, structured similarity algorithms, that compare two images and say how similar they are. So the smaller this number is, the more similar the images are. Or in other words, less quality or less loss has been made. You can see that even at 100 quality, some data is lost. Over here, right? Some data is lost even at 100 quality because these are lossy image formats. The mere way that they get encoded always loses information. But you can see that the curve of WebP is far kind of lighter, milder, and you can get to similar similarities even with a quality of 40 or that you would with a quality of 90 on JPEG. So you can be more aggressive with the numbers for WebP. Yes?
What does the similarity scale mean? Is it simply comparing pixel to pixel and give you that score, or are there also some psychological human perception things?
Yeah. So SSIM is an algorithm. There is also DSSIM. There are a variety of them. They try to factor in some human perception element to them. I don't think there's any one that is best. That's why I think there are multiples of them. I tend to use DSSIM when I run a test, and I feel it's a pretty good approximation. But that's sort of one person's opinion. So I guess at a high level, when you talk about whether something is 0.05 versus a 0.3 different, those would be very noticeable in any one of these algorithms. But when you talk about if you're trying to aim for the 0.1, it may be the different similarity algorithms would give you whatever a plus minus 0.05 delta there from what I've observed. Good. So how do we do this? How do we detect these components? How do we know that we have not done this? Whether excessive quality is there. So one thing is to run the SSIM. That's better, but it is more complex. A couple of easy tools that you can do is you can use existing analysis tools. There are actually many of these analysis tools. There's Zoomf, which is a premium-esque tool. There's GT Metrics. I'm going to name a couple here, which are Web Page Test, which is my favorite web performance tool. And it gives you some scores at the top, very, very simple. And one of them is about excessive image quality. So this is not about whether you've encoded at 75 and you should have gone to 65. This is about the fact that you haven't controlled quality and you have something at 90, which is also not deterministic to sort of find out, but you can figure that out. So web page test is probably the easiest thing to just sort of note whether you have many of these big images. This is also very handy to see whether you have third parties that you're using that are serving these massive images or advertisements, and maybe go to them and critique them or try to get them to fix their ways. When you talk about automating this and building this into your flow, you might be using web page test as well. You could also use page speed, which frankly the client has suffered a little bit recently, but page speed insights online is still a good service, and that would also identify all the different images that are out there. I don't have this on the slides, but if you did want to really optimize this, you could implement a binary search tree where basically you try to aim for a certain SSIM. I don't have this as a broad recommendation because I wouldn't start there, right? Like start with something simple. If you captured all of those that were sort of above 75, you're in pretty good shape. And now from here you can start sort of tuning to the next tier. So the quality section was much shorter than the image format section, but is no less impactful. As you saw from those numbers, just going from an image quality that is uncontrolled, at 85, at 90, and lowering that to 70, 75 could cut your image bytes by half sometimes. Any questions about image compression as a whole or about quality controls? Yes? Yeah. And unwieldy. So yeah, so the question is, how do you handle these in the pipeline when this complexity increases? Let me park that question. So this is the whole section of operationalizing image compression is because of that challenge, which I think this is becoming something where we strategically need to think about how we handle them, not just tactically. Other questions? Good. So let's go on. So, as we all know, it's really not about size. There are other things that matter. So once you've compressed your images and you have the smallest images possible, the next question is how do you load them? How do you get them onto the page? And that could be equally impactful in terms of user experience, even if not always in terms of like the payload of the page. So over here, again, I'll talk about two primary tips that you should factor in. The first one, which is most important, I think, in today's world of multi-devices, is sizing images to the device. I'll pick on Oracle as an example. I'm sure Brian Cantrell would be proud. But I could really have chosen many, many different images from many, many different websites that have the same behavior, same pattern. This is an image from their homepage a few months ago. It's really nice, nice and sharp. It's 100 kilobytes, which for an image of this size is actually not bad. And it has almost 1 million pixels. When the Oracle website is now responsive, so when you load it on a small page, you get exactly the same image, but it is displayed on a smaller screen. So it's only shown, this is, I believe, on an iPhone, it's only shown at an 866 by 240 pixel width. So it's the same image that gets downloaded, but it's shown smaller. So in fact, about 79% of the bytes are not displayed. They're just not there. So if a user zoomed in, for the few users that zoomed in and tried to sharpen in, they might see them. But for the vast majority of users, they have not seen that at all. This is 79% of the bytes, which translates to 68% of the 79% of the pixels, 68% of the bytes, and clearly we have sort of smarter compression algorithms, so some of that waste is compensated for by compression. And when you think about this is 2/3 of your page. So if they were to size that image to their screen, they would save 2/3 of the bytes on the pages, 2/3 of the image bytes on the page. Beyond the byte aspect of it, beyond the network component of it, the browser now also needs to load all of those pixels and read them in memory. There's no two ways about it. The browsers, no matter how sophisticated our compression algorithms are, they now need to show a bitmap on the screen. So they need to take this image, extrapolate it out, and show its bitmap on the screen. That bitmap needs to be held in memory. So For an image of this size, that's about 4 megabytes. And 3 of those megabytes are those wasted pixels. So it's about 3 megabytes of wasted memory. And on the surface, you might say 3 megabytes, I've got 8 gigs of RAM, it's not a big deal. But first of all, you have to remember there are 54 images on a page on average. Now, not all of them are going to be this big, but there are still 54 images on the page. And today, loading images is the primary memory hoard, sort of memory hog, or the primary consumer of memory when you load a web page on browsers, except for sort of fancy applications that do very sophisticated things in JavaScript. So for the majority of web pages, when you load the page, the majority of memory is taken up by these images. Also layer on top of that while you might have 8 gigs of RAM on your machine, for many of the mobile devices that you're browsing, you will not. In fact, 25% of new Android phones ship with only half a gig of RAM. This is new phones. It's a big deal. It's a big deal in accessing the next billion, talking about accessing emerging communities. But it's also significant on your sort of snazzy new iPhone 6s, because at the end of the day, those memory requirements are constrained. There are many other components on the device that are vying for that memory. So when you take a large image and you serve it to a small screen, you're wasting pixels, you're wasting bytes, you're wasting memory. And you're also asking the device to do more. So for the smallest devices, or for a small device, when they get this type of a large image, somebody needs to do the work of resizing it to the screen. It doesn't just happen. There's some compute that needs to happen to load that image, the big one, and figure out how to scale it down to the size that is displayable on the screen. And the kind of poor situation here is that the weakest devices that have the smallest screen and kind of the least CPU are least able to display these big images, so now they need to do the most work to scale them down. Team Cadillac did some work on this and tried to capture some numbers, try to figure out how long does it take them to do it. It's really hard. Our tools right now are still very limited in how much visibility do we have to sort of this type of a resizing and processing time. But it seems to be that for a decent sized image, it might be as much as 100 milliseconds. Now, think again that there are 54 images on an average web page. That could amount to a very, very substantial delay just from the processing of images on the page. There's an important debate going on right now, again, because of tooling, we can't really resolve it, about what is the primary bottleneck on mobile browsing. And there's a good number of people that believe that today, for mobile devices, it's really much more about the device and the processing of the device than it is about the network. When you're with your mobile device and you're on a good Wi-Fi network or a good 3G or 4G connection, maybe the network is not your bottleneck anymore, but rather the processing on the device. And these images make up a big portion of it. So hopefully, by now, you're convinced that you shouldn't send oversized images to the display. I could give you a million more stats, and I can definitely tell you that the vast majority of responsive websites and websites as a whole on the web today do exactly that. They just serve the same image to all the different form factors, and usually the best image, the biggest image that they have to all the different form factors. So how do we fix this? How do we technically serve the right-sized image to the right device? Once again, there are a couple of new evolutions in the world of kind of the web standards that make this much easier. I've been sort of telling this story for a few years now, and it's nice to have seen the transition from needing to recommend a JavaScript-based solution to things that are much more standardized. The first one is SRC set, or source set. As you can see it here, it's an addition or an extension to the image element. It supports this somewhat funky microsyntax that allows you to specify the width, or maybe you can also support an X parameter, but really width is what you want for the resolution. This is the width in terms of number of pixels on the screen. It's not a physical width. And it tells you if my screen is at least 1024 pixels wide, serve this large image. If it is 640 pixels wide, serve the medium image. And then because it's an addendum, it's another attribute on the image element, you can choose your default image in the source attribute. And it's your call whether to go mobile first and put the smallest image there, or if you want to go desktop first and put sort of the largest, the richest experience version there. Clearly, from a performance perspective, you're better off with the former. So source set is very simple. It's pretty well supported. It also supports a sizes attribute. Sizes is a little bit more controversial. there's a challenge where sometimes if you have an image, you might be loading that image, when you're on a smaller screen, you might be loading that image as a smaller percentage of that screen. Maybe you've resized it from being a big image to now being a thumbnail, or vice versa. Maybe oftentimes images that are the entire width of a screen on a mobile device would just be one column when you go to the big screen. So for those images, CSS dictates how big of a space they take up, or how much space they take up on the screen. However, when the browser comes in and wants to download those images, it can't do that. It doesn't yet have the CSS information to know how big or small it would be displayed. On one hand, we don't want it, I'll talk about the preloader in a bit, but we don't want it to wait to have the CSS. We want it to download the image as fast as possible. On the other hand, if you don't have those stats, how does the browser know which image to download? Let's say I had an image that was displayed 100% width on a mobile device and only 30% width on a desktop device. How do I know how many pixels should I serve? What size image should I serve? So the sizes attribute was a bit of a compromise. In the sizes attribute, you can tell the browser that this is roughly the size of the image that would be displayed on different components. This is a little bit of a repetition of your CSS. It is not at all functional, so sizes would not be used to decide how to display your image. It is purely another piece of information to help the browser choose which image to download at any given time. So it's a little bit more finicky. And maybe with that, it's kind of worth noting that I keep talking about telling the browser, letting the browser choose. And that's maybe the other thing to understand about source set, which is it's a hint. It's not a declaration to the browser. You are hinting to the browser that these are the versions of images that you have, and you're letting the browser decide what to download. Maybe the browser is right now running low on battery, or knows it's on a bad connection, and maybe it wants to choose to download a lower resolution image than what it has. Maybe the browser provided a setting to the user to say that it's trying to spare on network, you're roaming or something like that, and you're trying to sort of reduce your image or your general kind of data caps. So in those cases, again, the browser might decide to download a lower resolution image. So again, kind of there was a lot of conversation about what happens here, and the agreement was that the website knows what images are available, but the browser is the one that's in the best position to decide which one to use. And so source set is a hint, and in the vast majority of cases, the browsers would probably just follow instructions, but you cannot rely on that. So source set is fairly well supported today. It was driven by Apple, so that's why it's supported in Apple very quickly. And it's supported by pretty much everybody but IE, but Edge would support it. So it's very well supported, and you can use it today because it has the image source fallback. You can basically just add it to your pages and not worry about it. The second way that you can do this, in case, is a picture. So I talked about the hinting component when you talk about just sort of high resolution or sort of controlling the resolution of your image, serving a low resolution image to a low resolution screen. That's referred to as resolution switching. But sometimes, especially when you talk about a responsive website, there are also design considerations about choosing which image you want to download. That's referred to as the art direction. So for art directions, this notion of a hint and that the browser may choose to download a different image doesn't work. I want to be able to zoom in on the dog when I'm on a small screen, because adding all of this background would just make the dog disappear if I'm on a small display. So for those cases, you want something that is much more deterministic. And that brings us back to picture. So picture, as we saw before, supports the type attribute for supporting the image format type, but its actually original intent was to to provide a media attribute to say when to download which image. So it can provide multiple sources here, specifying sort of a CSS style breakpoint to say when to download this image. And then it can provide a source or a source set attribute to say what to do. So the guideline is, and picture is deterministic, so the browser would follow these instructions and has no say about it. So the guideline you should use is when it's really all about resolution switching, and it's all about just sort of controlling the bytes, you should use source set. It's simpler, it's cleaner, it's supported by a wider set of browsers, and it lets the browser make the right decision. If you need art direction, if you need to decide and control which image is displayed, use picture. But don't use picture only for resolution switching. No, picture is not quite as well supported as as a source set, it's on a good trajectory. It's supported by desktop browsers very well, but most notably on browsers, it's not supported by iOS. If you want to use picture both for the previous functionality about image formats as well as for this functionality, you should use a JavaScript polyfill that would make those work. It does mean that those images would now be downloaded using JavaScript, which I'll talk about in a moment, but at least the picture element functionality would work, and as browsers build support for it, the polyfill would just switch to native. Okay, so we talked about the fact that you need to download the right size image to the right device. We talked about how can you do this using picture and source set. But the next question is, how many variants of this image should I have? I mean, do I need to create a different image variant for every pixel variation? If I have a screen that's 200 pixels and 201 pixels wide, do I really want to generate another variant of the image? The generation of the images is expensive and time-consuming. If I generate all of these different variants, my cache utilization would get reduced. More of these images would not be served from cache. And for many of these cases, it's just unnecessary. I mean, does it really matter at a 1-pixel resolution that I will switch? But then if it doesn't matter at a 1-pixel resolution, what should I do? How should you decide how many breakpoints to create for every image? Now, this is a question that's not well answered today yet. There's still some tooling that's lacking to make it easy. But I will give you two sort of means to judge this and to make this decision. The first is to look at your users. So the first thing to do is you can look at your Google Analytics or at your whatever analytics and look at what devices are your users using. And just like anything in performance doesn't have to be perfect. So you can identify the common, the frequent devices that are used by your actual visitors, and then make sure that for those you have a specially crafted image. So in this case, you might see that your users are coming based on these resolutions of 360 by 640, 768 by 1024, and you can make sure that for those popular client resolutions, you serve the right size image. The second thing to look at is the images themselves. Not all images are created equal. Some images, like an icon, might even be an SVG, and you just serve that for all clients, the same image. Others are just very plain. They're simple. They're two colors. They compress very well. They're too small to care about creating variants of them. Others, like this one, might be very complex, and it may be that by creating even small leaps, by sort of creating a different version for small leaps in resolution, you might yield some substantial or notable file size savings. So there's a really good post by Jason Grigsby, which I link here. I'll post these slides. I recommend you read. That says this a little bit more methodically. But basically, the suggestion is take each image and try to assess, try to encode it in a variety of ways, and see what are the file size differences that you yield. Now, unfortunately, this is right now very much a manual process. So for this one, you might run through this process and get 9 or 8 different breakpoints here. For this image, which is much more sort of clean colors, just sort of a simpler image from an encoding perspective, 3 breakpoints might yield. So you can create a policy of sort. You can say, I want to only create a new variant if it's at least 10 kilobytes in difference in size. So you start with images that are above 10 kilobytes to begin with, and then you go through this process. Unfortunately, I'd love to recommend a tool where you just magically pop this thing. I know of some image management players that are working on such tools, but for the meantime, we don't have those. So before I close off on the responsive images piece, I want to get back to FLIF. So I mentioned earlier on that FLIF is a progressive format, and what's very interesting about it, maybe I should take a step back. So a while back, in a responsive image community group conversation we had in Paris a few years back, Yoav Weiss suggested the magical image format, which could actually have one file that just the first X bytes in it are suitable for this resolution versus the next X bytes of it, Y bytes of it are suitable for another resolution. And I believe you even started working on this at the time. It never went anywhere, and frankly was kind of forgotten. But now with FLIF, this capability is actually kind of being embedded. So if you look at this image, it is about 300,000 bytes and whatever it is, a pretty substantial amount of pixels. If you create a smaller version of it, you can actually encode it such that the first 80K bytes of the image serve a smaller resolution image. So you can have one file and just request the first section, the first set of bytes, and you would get a lower resolution, but a complete lower resolution image of that image. And you can even do multiple variants of it. So you can take the first 37K bytes out of it and get it. So this is brand new, like this entire image format, and I don't know how it would manifest, but I think it's pretty cool and may kind of help address some of this problem where we have one image, one actual source image, and it's just encoded such that the next range of bytes in it would give us the result that we're aspiring to. Might even allow for some streaming options where we can download a chunk of bytes, show it on the screen, and then decide whether or not to download the remainder. There have been some experiments on doing that with progressive JPEGs that never really panned out. Yes?
Are those images, are the complete images just one after another, or is there something, if I get the first chunk, like the 37K, I already have information I can use when decoding the slightly larger one.
Yeah.
That would be actually cool. So, and then with displaying it, so I get the very first version, scale it up in software, and then in the background I get the other stuff and my quality.
Yeah, increases. So the question is basically whether these are complete, and can I actually render a full-size image with just the smaller images progressively. So that's actually exactly what happens with JPEG progressive encoding, which you can show like a grainy image and then make it sharper and sharper. So presumably it can be done here. Frankly, my knowledge of FLIF is not that deep. So I would recommend you go to flif.info. If you Google FLIF, I think it's a fairly uncontended Google term. I'm pretty sure you're going to get to them first result. And you can reach out to those components. And as I said, also there's been much progress over the last few months. So maybe some of these answers are still in flux. Okay, so this was it about sort of sizing images to devices. There's a lot to be said here. Again, this could have been sort of a full talk of its own. But basically, first of all, size images to devices. Don't just discount this. This is a major waste of bytes, of memory, of processing time that you're causing your weakest clients. And mobile clients are your primary clients at this point. You can use picture, you can use source set, and we're not quite there, but you have at least some ways to sort of address or think about how would you choose the different breakpoints to serve to the different clients. Any questions about sizing images to devices before I go on?
The debate between network being the bottleneck and device being the bottleneck. I don't know that before. I mean, is that really true?
Yeah. So this is the question is whether the debate between device or network being the bottleneck is that real, or is that just kind of people making noise? There's stats to demonstrate both cases. It's not. This is just to clarify. This is not just about images. It may be that for images, we just really lack visibility here. So it may be that for images, clearly the network is the bottleneck. But when you talk about the web page as a whole, and you talk about constructing the DOM, and you talk about running the JavaScript and creating all the sort of fanciness that goes around that, yes, there are stats. There are definitely concrete stats that show how, for certain pages, the device is the bottleneck. For certain pages and for certain devices, for certain network conditions, the device is the bottleneck. The only question is what's the majority. The other aspect to consider, again, I didn't dig into it here, is when you talk about a mobile device, there are other constraints. For instance, if you download a big size image and it needs to be resized to something small, oftentimes that needs to be done by the GPU. So that means you have this big image in memory. You need to push it to the GPU through a bandwidth-constrained bus between the CPU and the GPU. So now that becomes the bottleneck. And in some cases, it literally would take you, for a very big image, it might take you 2 seconds just to get those bytes through. They happen in parallel with some others, but it would be very constrained. So yeah, on these devices, there are many other parameters that factor in. And oftentimes, with a mobile device, you're on a pretty good network. So, yes? Is Safari showing signs of implementing picture? So picture has been, I'm pretty sure that the picture implementation has been built for WebKit by Yoav Weiss. And I guess we're all sort of waiting for iOS 10. So we don't know. We don't know. I think there's hope. There's sort of indications that it will be supported. There's a little bit of a chicken and egg there as well. If many websites choose to use it, there would be more motivation for them. I think right now we're at the point where it's probably more a decision for them than a technical limitation. Yes.
You haven't mentioned anything along the lines of things like basics for encoding, or whether you could or should cache on the client side as well. If these sort of put into app cache or something, these techniques have been helpful, or they cause additional issues?
So the question is whether techniques like base64 encoding of images and putting them into resources, are those helpful or not? So for the most part, you want to revert to. So I'd say this: processing a base64 encoded image is much more expensive than processing a native image because it would go through multiple additional layers in the browser. So the question is whether, for your situation, is that helpful in getting you savings elsewhere that account for those. If you were to store this in base64 in app cache or in local storage, now you would need to read it from local storage. You would need to use some JavaScript to parse it out, and then you would need to pass it on to a canvas or something like that. So those are fairly expensive. In the majority of cases, I would advise against it. At least unless you really, really fine-tuned your component. In some cases, I believe the FT app, for instance, used techniques like this to do some better offline experience. That was worth it for them. Okay, let me move on so I actually get through the next sections, because I realized I'm actually going to be a little tight on time here. So the second tip that I have around image loading is to talk about prioritizing critical images. So up until now, everything we talked about was waste, was sheer waste. We download too many bytes. We could have compressed the image better. We could have reduced the size of the image for a smaller device. We would download fewer bytes. In the next section, I want to talk more about sometimes waste, but also about priorities, about which images do you load first. So if you look at an average web page today, the majority of the page is below the fold. These are 3 examples of different websites. Actually, I originally had Steve's blog post here, which shows the same thing. The vast majority of web pages on the web, the vast majority of content is what's called above the fold. There's a lot of contention about the term above the fold. It comes from the newspaper world, where you would have folded papers, and only the thing that's above the fold would be visible when it's just laying there on the stand. And there is no digital fold. You just scroll. There is above the scroll. I like the term above the fold better. I'm going to use that one. Sue me. If you look broadly, again, I ran a broad test just using web page tests. It's so easy to just run these 10,000 page tests. And it seems like about 62% of the pages, if you just look at the top 10,000 websites on Alexa, and you just load them in a desktop browser, you would find that 62% of the content of the page is not visible at page load. And about 80% of the image requests are made by pieces that are below the fold. So this is initial stats from what I ran, but it corresponds to many of the anecdotes that we've seen as well. Let me show you an extreme example of this that happens in, well, you know what, actually, let's kind of veer off that. So this is one challenge that we have, right? We have all these images, we download them, so users oftentimes do not even scroll, and therefore those images are never seen. But even when they do scroll, they don't scroll right away. They first look at the content that's there. That's oftentimes, by the way, the content that's above the fold is oftentimes trying to drive them to do some action, like navigate away from the page, to log in, to register, to read some article. The other challenge that happens is that we use various techniques, especially in the world of responsive design, to hide images without avoiding their downloads to match our design. So this is another example of waste. This is a bit of an extreme example. I was at Web Directions last year, awesome conference, you should check it out. They have a very kind of visually rich web page. This is the full page. It has the same challenge or the same kind of common property of having the majority of it be above the fold. And when you go to the mobile version of the page, all of those images are gone. They were actually bold enough to put an image display none. There are literally no images displayed on this page. And this is the mobile page, or how it looks. There are no images here whatsoever. However, those images have been hidden using display none. And display none is a CSS property. And no CSS property, no styling instruction would affect the downloads of core page elements, period. styling would not affect downloads. The only tiny exception to that is in some cases, a background image that is specified in CSS, if its parent elements are just so, would not be downloaded. So as a result, if you load this page on mobile versus on desktop, there would be the same number, large number of images and bytes downloaded on images. So this is a slightly extreme example, but a variation of this happens on practically any responsive website out there. So between those two cases, we have many images that are not displayed or that are only displayed later on. To do that, to sort of address this, to avoid this waste, unfortunately today, you still need to revert to JavaScript. You need to switch to a technique that would do lazy loading of images and only load those images if they are visible or when they come into view. So I'll show you an example of this. This is slightly more complex JavaScript, and I'm kind of half-hearted a little bit about recommending a JavaScript solution because of some problems I'll show. But I think it's an important problem to, again, kind of weigh against your considerations or the value you get or the cost it gives you. So the way to do lazy loading images is roughly like this. You have an image tag that points to a book. You replace that with an image tag that looks roughly like below, which is instead of the actual image being the book, the actual image is a 1-pixel GIF. Surprisingly, for 1-pixel images, GIF is smaller than PNG. And then you have a data source, which points to the real element. And at the onload attribute, this is the onload of the 1-pixel GIF, you call a JavaScript function that would load the real image from data source. The JavaScript function would look like this. This is actually functionally working. So it would go pick up the data source attribute if it exists on the element, and if it does exist, and the image is above the fold, which is a slightly complex but not that hard calculation to do, or you could also just ask, is visible? There is a new visibility API coming into browsers, so once that's there, this would be made even more, even simpler. So if you've determined you want to load the image, remove the onload event so you don't get into a spin here, and then copy the data source attribute onto the source. That would trigger the browser to download the real image. So it's fairly simple, except if you do the is above the fold, you also need to now repeat this check as the fold and the visible area changes. And that's where it becomes a little bit more complex. So you could do this. That became way too long for me to capture on these slides. But you could repeat this check on viewport, on scrolling, on resizing. Again, the page visibility API or the element visibility API that is being worked on right now, I think it's in draft mode, might even shipped in one of the Chrome canaries, may make this easier, but for now it's not there, so we can't really rely on it. So you could do this, and this would tackle the is above the fold component. And I'm not quite as complete with my suggestions here, but you can keep that. Another path that you can take, which is simpler, is to, instead of lazy loading them, defer load those images. So in this case, you do the same function or the same flow, but your load image function looks a little bit different. If you've decided to load the image on the spot, then you would actually go through and you would run copy all the lines until the else are the same as they were before. But otherwise, you would add the loading of this image to the onload event. So what that means is at the onload event, all of those images that you've previously decided not to load will be loaded. So in this case, you're not sparing yourselves any bytes, but you are prioritizing the loading of the images that are above the fold that you've deemed more important to be loaded first, and therefore the invisible images, the below the fold images, do not compete for bandwidth with other resources on the page. There's imperfections in this one as well. This is a fairly complicated topic. So I would say don't start here. But if you're at the point where you've done everything else, and if you look at your page and you see there's plenty of waste, then you can do those. So the key reason not to do this is the preloader. So let's talk a little bit about the preloader. I see I'm going to be tight on time here. So it's a good thing we have Q&A during, because I might not have time for Q&A at the end. So let's talk a little bit about the preloader. How many people here know about the preloader's existence? Okay. So the preloader is a component that runs. It's a secondary parser that runs when a page is loaded to try and identify resources. Consider a page like this. It's a fairly simple page. It has a script, source main.js. It has a CSS file, and it has those images below. The browser goes off and constructs the DOM. And as it does so, it encounters this main.js file. And a script, when you construct a DOM, a script might do all sorts of crazy things to alter the subsequent parsing of the page. For instance, it could document.write at the beginning of an HTML comment, and everything that follows might become a comment. Or it might add elements. It might navigate away from the page. So because of that, when the browser parses and builds the DOM, when it sees a script element, it stops. It actually has to go, stop, wait, go fetch the main.js file, wait for it to come back, run it, and only then continue building the DOM. And that's fairly hard set. There's no real way around that. However, in the vast, vast majority of cases, those scripts are not going to do those wild things. They're not going to write something crazy. And therefore, it's wasteful for the browser to not begin downloading the subsequent resources while it's waiting for this main.js to be downloaded. So for that purpose, precisely, the preparser was created, I believe, around IE7, around that timeline, and has been improved since. And really, it's a speculative parser that tries to go through the page and understand which resources should I download. And it's making guesses about how to best utilize those components. Now, the speculative parser has a different challenge, which is, OK, now I've seen all of those resources on the page. What should I do? Should I just download all of them? That would mean that those image bytes are downloaded alongside my JavaScript bytes, and that might make my JavaScript bytes download slower. So the DOM construction would be slower. Now there's all these resource contentions. I've got only so many connections. There's only so much bandwidth. There's only so much processing power on the device. So the preparser employs heuristics, employs some logic, some non-standardized logic to determine which resources to download at which time. And this differs, especially with regards to images, between different browsers. Images, on one hand, you really want to download them faster because they're a very significant visual component of the page, and there are many of them, so you want to get going. On the other hand, images are the least important component in terms of the page's function, and you want to prioritize JavaScript and CSS over them. So browsers employ all sorts of techniques to block or not block image download based on waiting for JavaScript and CSS download. In IE7, so this is basically the inception of, or actually I think this is the inception of the preloader. This is the before, sorry, my correction. So this is before. IE7 was the last one to not have it. I think IE8 is the one that introduced it. And when you load this in IE7, you will see that the JavaScript file is downloaded. And then when that's done, the CSS file is downloaded. And then when that's done, the images are downloaded in parallel because they don't block each other. You look at a modern browser, you look at a recent Firefox, you will see that the JavaScript and the CSS file would be downloaded in parallel. And that's true for practically all browsers. All the JavaScript files and usually all the CSS files would almost always be downloaded in parallel up until they hit a connection limit. But no images are downloaded until all of those JavaScript and CSS are downloaded. So far, so good? In Chrome, there is one connection allocated for image downloads while the CSS and JavaScript is downloaded. So it's some sort of compromise. You say, OK, I want to download JavaScript and CSS more. I care about them more. But I know there's going to be some idle time. So I'm going to open one connection. How much damage can one connection do in terms of bandwidth utilization? Let me just sort of start getting those images. And then IE11 said, free for all. I don't care. These are resources that are on the page. I want them. And I'm just going to get them. And not going to let anything get in my way. And they just download all of those. So very different behaviors. There's no standard for it. Oftentimes they're not documented. You just find those out from running them. And the reality is, if you look at stats from Chrome, that the majority of image downloads are actually triggered by that preparser. No matter, there's all sorts of logic and whether it was blocked or not. But the preparser is something that we really should care about because it initiates the download of most of those images. So if we've switched to our technique, to the JavaScript technique that I've just mentioned right now, of loading images with JavaScript, what that means is that until our JavaScript ran, the browser is not even aware of our new images. So it would download those 1-pixel GIFs very quickly, but it is not even aware of our images because our JavaScript would only run when the DOM construction gets to it. So we very explicitly said, you will not know about our images until all of those JavaScripts have been fetched and executed. So that means everybody is going to behave. This is, I think, a misnomer here. This should have been the Firefox sign. So everybody's going to behave like Firefox does, which is hold until all the JavaScript and CSS has been done, and only then I will download it. This is a consideration. Again, unfortunately, in some of these cases, I have a very concrete statement about what you should do, and in many of these, it's just about be aware of this and make the right choice. It means if you were to apply lazy loading of images using JavaScript, you would have less waste of bytes, but you will hurt the preparser, and you would introduce a dependency on JavaScript. To make things worse, we are coming up on an HTTP 2 world. HTTP 2 is now shipped on HTTPS website. You would see more and more websites that use HTTP 2. In HTTP 1, browsers had to employ some logic like, do I download the JavaScript first, the CSS first, or do I add on images first? In HTTP 2, as well as Speedy, there is a built-in priority mechanism. So the browser can actually say, I want the JavaScript file, and that's a high priority, and I want this image as well, but it's a low priority. So the server can say, oh, I understand, but I am fetching this JavaScript file. I don't have it yet. In the meantime, let me send you this image. So bandwidth utilization can be much smarter and much more server-driven. And as a result, you would see waterfall charts that are much flatter, like you're seeing here. The browsers are going to get much more aggressive and just make these requests. This is the preparser making these requests. So the preparser is just going to see all these resources and just send them out. The overhead of a request is going to be lower. The prioritization is going to be better. And therefore, the damage of switching to JavaScript-based image loading is going to be greater. So very much a trade-off, right? I used to be a little bit more in favor of the JavaScript-based loading. I'm now a little bit more on the fence. So 2 pro tips of things that you might consider anyway. In case you, like me, cannot decide, then these are 2 techniques that you might sort of use that are sort of in between. The first one is low-quality image placeholders, LKIP. And the logic here is very simple. Instead of the 1 pixel GIF that I mentioned before, do the exact same thing, but put a low-quality version of your image in there. So what that means is that when the page loads, the image is going to look like this. You can go quite low. Again, that's kind of a design consideration. And then at the right point of JavaScript, you would load the high-resolution image. The waste here is by the fact that you've downloaded that low-quality image. And for high-speed environments, oftentimes, those high-resolution images would come in very quickly, and it was just wasteful. But the advantage is that if you're in a condition or in a situation where the bandwidth is constrained, the low-quality images would show up very quickly. The page would be usable faster. So this is very much a user experience optimization at the expense of actually adding bytes to the page. But the low-quality versions are going to be very small. So I'm a fan of this technique, and this is what I employ. The second thing you can do is you can do selective lazy loading. So that means, and actually the Guardian website is a pretty good example of this. So if you look at their top page, this is the top of their page. They have they have source set, they have sizes, they have this responsive images, and it just has source and source set. It's a native image, just natively loaded. Nothing, no fanciness around JavaScript. But if you look at the full page and you look at the images that are below the fold, those are served with this class that says JS Lady Loaded. All of the source set and the sizes attribute are now prefixed with data. And the source is now a 1 pixel GIF. In this case, a base64 encoded 1 pixel GIF. So this is interesting. They've employed some smarter logic in their content management system on the server side to determine which images to prioritize, and they make those native, so they would be loaded as fast as possible. And they choose the rest of the images to download those using JavaScript, and therefore only load them if necessary. It's a great technique. It requires more work. It still suffers from the fact that when JavaScript is disabled, those images would not load. I would argue that's not a huge consideration these days, but again, a consideration for you to keep in mind. So this is a great technique. It just requires the bar is higher for you to employ this. Okay. So that was it. This is a little bit of an information overload because we're going through a different series of systems. I hope you're still with me. So we talked about image compression. We talked about image loading and how to load images wisely in your page, both to avoid waste and also to intelligently load the important images first. I'm not going to pause for questions now, as I just sort of do a very, very quick section here about operationalizing image optimization, right? We've talked about all these different things. Clearly, images are no longer simple. It's not just put an image tag and run it. There are many, many things to consider. How do you cope with this? What should you do when you build something into your pipeline, when you build this into your operational mode? How do you deal with these image complexities? So I'm just going to have 2 quick slides here and high-level tips. First of all, encode well. Choose your encoding tools carefully. There are many tools here. I started listing them, and it was just too long a list. So I picked one, Image Optim, which is it's a bit of a cheat because it actually combines many other tools to apply a variety of optimizations. But just remember all the things that I mentioned before. A quality curve is not a standard. It's different from different components. As I mentioned to somebody here before, do not use Photoshop exports for it because they're not well encoded. These image formats are far more complex than what I've mentioned here and what we usually think about. There are different implementations that can yield very, very different results for each of those. So choose your encoding tools well, and you could easily shave many, many bytes without losing anything in the process. And most of these encoding tools are free and open source. So it's really not a costs thing. It's just a choice of which one. And as I said, if you want to choose one, use Image Optim. I'm also cheating a little bit because this link here to the benchmark also numbers many of the other tools that you might want to consider in that list. And the second tip that I have in this one is don't do any of that. Instead, offload this problem. I believe that today, image management or handling the complexity of images has gone to a level of complexity that it's very worthwhile for you as a business to offload that to somebody who specializes in it. It used to be simple. It used to be just another little thing that you do in your content management system or in your pipeline. I believe that today it's become very complex. For the vast majority of you, it is not your core competency in the organization, and there are now good tools out there that can help you deal with that yourself. We've got many variants, many of these images. We've got new image formats coming into the scene. We've got moving HTML standards. So you can use a tool that is built for that focuses on that from a team that does nothing but image management and image optimization, and use those. The vast majority of those tools would work in this fashion. So basically, you're putting some sort of proxy in between. Your CDN might have those capabilities. They might be integrated with it. Some of them are image transcoding solutions. So the cases where you still need to make the decisions, and they just make it easy for you to tweak and modify them. Some of them are full-on image management solutions. So it means you actually post the images to them, or maybe you still proxy them, but there's some intelligence in the service itself to decide what image to download at which time. Clearly, the first is, one level of effort offloaded from you. The second is more. So, I'm a big fan. I would highly recommend doing it. I'll give you kind of 2 ends of the range here for tools. One is I'd be remiss. I was a part of building it. Not to mention Image Manager. This is an Akamai tool that's been recently launched now. Still a little bit early, still a little bit light on the functionality, but has the core piece of functionality. It's Akamai. Clearly, it's a little bit more premium. Another tool that I've mentioned here before in the different data is Cloudinary, which I'm a big fan of. I think this tool is much more today feature-rich, kind of comprehensive. It has a really good free tier, so it's easy to try it out, to basically just go sign up. There are other tools out there. Again, you can't enumerate all of them out there. My primary recommendation is just pick one. I think for most of you, this is not your core competency, and investing a little bit of time in choosing the tool to use would probably save you time and money and eventually make your sites faster. Okay, so that's it. Just to sort of quickly recap, images matter. They are a big part of web pages today. They are a big part of both the weight and the page load time. They are only getting more and more complicated, and therefore you should pay attention. They should be a part of your lexicon. There are 3 high-level things that you can consider about how you tackle them. You want to set up some image compressions to make those, to be able to communicate the same visual with as few bytes as possible. You want to intelligently load those images on your page, and you want to think about how do you operate this. If you're doing it locally, make sure you encode well. If you're offloading this to a service, choose a service, make this problem handle well. And on top of all of those, I would say that with regards to images can get out of hand. Image sizes can get out of hand very, very easily. So I do encourage you to enforce a performance budget, set some thresholds to say our page should not go above X size, and specifically N images and Y image bytes on it. There is a whole book that can be written about this, and in fact, we have, so myself and some great names, other team, Colin, Mike, Yoav, and Nick are putting together a book. There's an early release of it that you can find online on this link. I'll have it on the next page as well. And I believe Akamai would be giving out free copies of those in their booth once the booth starts tomorrow. So that's it. Maybe I'll take some questions. I've got 5 minutes. Yes?
Actually, we are considering to use libraries like the BBC imager to manage both the responsive parts
Yeah.
and this lazy loading. Is this any different to what we discussed earlier today? Just as a fully fledged implementation of JavaScript approach, and therefore that's the whole pitfall you mentioned.
Right. So, so the question is about using BBC Imager.js tool. Whether that is equivalent or replacement. So, Imager.js really preceded SourceSet. Today, I would recommend you use SourceSet. Imager.js was built expecting you to have a transcoding service in the backend as well. So, if you have that, then that's great. I encourage you to have one of those. In the case of the BBC, it was one of theirs. Also, I know they're also kind of scrutinizing whether that's the right move or not. I think today I would advise against using it. I think SourceSet offers what you need and shaves you the need to use JavaScript for that loading. It was great, and I'm a fan of it, but I think its time is up. Yes.
Do you know much about how Google goes and crawls your pages for images, and then which version of an image the Google crawler will download, and how does lazy loading affect that?
Yeah, so the question is, how does Google handle lazy loading or JavaScript-based image loading? I guess I'll say 2 things about images. So first of all, in terms of JavaScript, Google does explicitly say that they do execute JavaScript. You can easily test. These pieces of JavaScript would not be that fancy, and from what I've observed, they do capture those. So usually, I think you would be fine. If you were to put the low-quality versions of there might be fine, and you can also choose to serve a different page. It's not considered cloaking if it's just one that doesn't have the JavaScript on it. The other thing to note about Google that's interesting, though, in the case of responsive images, is so today with responsive images, there's a question I didn't quite touch on here, which is, do you use the same URL or do you use multiple URLs? So do you use image-low-q versus image-high-q for low quality and high quality, or do you just say this is image, and depending on whatever other parameters, whether they're query parameters or, more interestingly, if they're cookies or indicators in the request, I serve a different response. There's an argument to be made, and I've sort of heard it from some search engine optimization experts, that you're better off serving the one URL. And the reason for that is, there are many reasons for that functionally. You might kind of preserve some agility, but also when Google sees a low quality and a high quality version of the image, it has to figure out which one does it show in an image search. And it has to spread the authority of them, sort of spread the ranking of them to a certain extent. So when you give it multiple variants, there's no 2 ways about it. It has to make a decision, and clearly it's going to spread the ranking of them to a certain extent. When you give it one image, then it's much easier for Google to just sort of rank that image high. So the claims that I've seen, I'm not an expert on this, so take it with a grain of salt, is that if you serve if you care about image search and image search ranking, you're better off serving those images from a single URL and sort of conditionally delivering different content. Okay, so I think I'm up for time. So I'm still around here for questions, and I'll be around throughout the conference. Thank you.